So again, this is a small introduction to the retuning process as applied to large commercial buildings. My name is Jerome Galliano of Performance Systems Development. And what is this retuning process? This is a systematic process for going through and identifying and correcting operational issues and problems, typically at no or low cost. It's a process that was developed by the Pacific Northwest National Laboratories in collaboration with other organizations. And there's basically two processes. There's two paths you can really go down. There's a prescriptive one and a data-driven one. And the prescriptive one is geared towards small and medium-sized commercial buildings. And we gave a little intro webinar to that several weeks ago. If you're interested in knowing more about it, you can email us and we'll send you a link so you can watch that webinar. And that one, again, it's more hands-on, in-field kind of diagnostics of what operational issues are going on, and a lot of it's sort of maintenance related. The one today we're going to talk about is a data-driven approach for large commercial buildings, and these buildings typically have a building automation system. So it's a very data-rich approach. We take the data trends from the building automation system and analyze them for issues. So, is this retuning process a one-time thing you apply, like you apply for LEED or you do an audit? And the answer is really no. It's best utilized as part of the maintenance program, and it's just building it into your maintenance practice. Typically, the first time you do retuning on a building, it's the most time intensive because you're understanding your building automation system, getting the data out of it, setting up the trends, doing the initial analysis, just understanding your building. But ideally, you want to do this over and over time because a typical building, right, the energy usage of a building typically increases over time because things go out of control, people override settings. So what retuning does is, if you see the line that's increasing over time, it helps bring the energy usage down through correcting things like simultaneous heating and cooling, static pressure being constant and way too high, things like that. But again, if you only do retuning once, yeah, you get here, but over time, those settings are going to be overridden, something's going to happen, and your building's going to go out of control again. And so ideally, you like to apply this retuning process once a quarter, maybe even once a month if it can really be integrated into your overall maintenance process. So it's, again, a data-driven approach. Typically, it's for buildings that are much larger because typically these are buildings that have a building automation system. You can't really apply this process without having that kind of data trends. You could use short-term data trends from field loggers if you wanted to apply that, but really that's going to be very time intensive, and this is meant to be fairly low cost. The biggest cost is going to be the consulting time. If it's an outside consultant doing this for your property, or if you're training your staff, then it's, you want to minimize the amount of time on your staff in doing this. So really you want to utilize the data from your building automation system. I apologize about this line here. Ignore this third bullet point. This is not typically for packaged rooftop units. Sorry, that was a bullet point from the small building retuning. This is looking at typically VAV type systems, the variable air volume kind of air handling systems, large air handlers. It also looks at the chiller plants and boiler plants, and as well as looking at the mixing, your heating, cooling, mixing boxes in your part of your VAV system. So sorry, ignore that third bullet there. Who is this intended for? Really building operators, service providers, and control vendors, or outside consultants, outside engineers. Does retuning work? Yes. There's a lot of case studies that we have done by various organizations, a lot of them through PNNL as well as DOE, but this is a chart from the tool called ECAM, the Energy Charting Analytics Metrics. It's an Excel-driven tool that PNNL put together, and the tool does many things. It does, and very
detailed M&V kind of stuff. M&V, very, in compliance with guideline 14. And if you could please mute your microphones if it's not muted already. So this three lines here, blue is before retuning, red is after, green is while the retuning process happened over the course of a year. But you can see this is the hourly profile. The typical hourly profile dropped pretty substantially, almost a 15-20% savings. So yes, retuning can work. Here's a case study of a large federal facility, about 2 million square feet, several large chillers, variable air volume systems, about 100 air handlers. And the kinds of measures that were done to correct operational issues are these. And these are very common things to find. I mean, the occupied versus unoccupied modes. The BAS was set up at one point where the unoccupied versus occupied modes were set for a certain time of day, and maybe the schedule of the building changed, but the building automation system was never updated. They corrected operation sequencing of the chillers. Sometimes you have 2 chillers coming on first thing in the morning instead of staging them. A lot of times resets on the discharge air, or just resets in general of your static pressure of a lot of settings, are either not set or they've been overridden over time. So there's a lot of issues with these buildings that are actually pretty easy to find using this retuning process and the ECAM tool that PNNL provides. And so in this building, here was what happened as a result. They had about a 16% reduction and essentially a return on investment, or a simple payback time period of 3 months. I mean, it was very quick. And again, the cost is really the consulting cost if you hire someone outside, or your hours for your maintenance staff. Typically, the only kind of capital costs are possibly replacing sensors if you have faulty sensors in the field. So, and if you have any questions, please feel free to throw them in the question box or the chat and submit them. Just going to show, this is an example of what the ECAM tool can show you. The ECAM tool it can look at meter data, like your electricity data, all interval data or monthly, but typically for these buildings we're looking at interval data. And it can also be used to do the actual measurement and verification of savings after you establish a baseline and measure before and after performance. This is just one example where ECAM can give you monthly profiles. It can give you by day type, like a weekday versus weekend or holiday. It can give you profiles of energy for each day of the month. It can do a variety of things with just your energy data. But probably the real power for the retuning process is setting up these standardized sets of charts to help you look at the building automation trend data. Things like set points and temperatures of the air out of your VAV system, or your chiller water temperature, is there a reset on it, the cooling tower performance. So ECAM has a bunch of predefined charts that helps plot the variables, the typical variables that you need to compare one against the other and see, is something going wrong in my building? And this is an example of one of the charts. It's some example data from Large Building. In this case, we're looking at weeks of time. It looks intimidating, or as a friend of mine posted to me on LinkedIn, he said, God, this looks like some scribble on the back of a napkin. But what this is, and you don't want to, first is not to be intimidated by it. And at first it is kind of intimidating, or what are we looking at? But the red line here is the outside temperature, just plotted, just dry bulb outside temperature, nothing fancy, somewhere between 70 and 90 degrees, daytime, nighttime, over the course of about 8 weeks. The blue lines are your static pressure in your VAV system. And so the green line here is before retuning and after retuning. And so what we have going on here is the static pressure is jumping way up to 2-3 inches of water column. And that's really high for a system. Higher the static pressure, the more your fans are running, or the harder your fans are running, drawing more currents, using and wasting a lot more power. After the retuning process, you're able to reset the controls to, dial the static pressure to have basically a reset and bring it down
and a new set point somewhere around 1.25, maybe as high as 1.5, depending upon the outside temperature. So this is a large, knowing the affinity fan laws, this is a very large electricity reduction when we're talking about these large air handling units that have very large distribution fans. So an example of good and bad operation. And next we're going to have an example where you get to try to answer what's going on. There's a couple questions. I'll probably hold them to the end, but this one I think maybe is pertinent right now before we go into an example for you all to answer. Someone says, what is usually the cost of a retuning process like this? Does ASHRAE level 1 or 2 fall under this? And no, this is not an ASHRAE level audit. Again, it does include, or it can, and it's kind of recommended to include what they call a walk down or a walk through of the building to make sure you understand which air handlers and zones you're looking at. And for a large building like this, or one that had the 100 air handling units, you're typically not going to look at the data of all 100 air handling units. That's just too much to look at. You're going to select a few zones, select a few air handlers, or do a sampling. And the P&L process has a sampling protocol of how to go through and decide how many air handlers per floor, per zone should you sample. And look at those first, and maybe you do the other ones the next quarter and the other ones the quarter after that. What does this cost? It really depends. Are you talking about your internal staff costing or cost? I would say for when we've done this on a couple occasions or assisted in the process, you could be talking about $10,000 to $30,000. It really depends upon how much the staff can help the outside consultant do it, or if the staff are being trained well enough and they can get the data out of their own building automation system, then and integrate this into your operations and maintenance procedures. Then really it's no cost to you. It's just a new part of your maintenance process, which some people say they don't have any additional time to add to that. So the question, clarifying the question was, what is the consulting cost? As I said, maybe somewhere between $10,000 and $30,000. It really depends upon how big is the building, how many systems are you going to look at, and how familiar are you with the building automation system for that building. So we can maybe get into that a little more at the end, but again, it's really how many systems are you going to look at, and kind of racking up the hours of getting the data out of the building automation system can take a lot of time, especially if it's something that's more proprietary or a system that only the control vendor can give you access to. That we've done that before, where the project drags on forever because the control vendor doesn't really want to be that helpful. In other cases, it was very easy to get the data out. It was an automated logic system, pretty straightforward to understand. We had to learn it, but it didn't take very long. So I'd say, barring getting the data, analyzing the data in the eCam tool and coming up with recommendations is probably, in the order of less than a week, like several days, depending upon how good you are at the tool. So let's move on to an example. There's some good questions here. I'm going to answer the questions at the end. Some other great questions, but I'll hold them to the end. Let's move on to this example. So I showed you one example here where we have good, bad data, bad performance beforehand, good performance after the retuning process. Now let's look at another set of squiggles, another trend data, again, from the building automation system. And you decide, this is not a before and after picture like last time. This is just, we're looking at the trend data before any corrections are made to the building, and is this good operation or bad operation, and why? I think you have access to the chat. If not, if you can, just so the questions don't get all messed up, if you can add your response to the chat box. I believe attendees can raise questions, attendees can view. Maybe you don't have access to the chat. If you do, submit your answer in the chat box. If you don't, I guess submit your answer in the question box. But is this good operation, bad operation? What we have here is, let's see, Thursday. We're looking at only a couple days here, like 2 days, daytime, nighttime, daytime. you have chilled water signal. So this is percent open of your chilled water valve, and percent open 0 to 100, or fully closed to fully open of your hot water valve. Right. These are the cooling. These are the chilled water and hot water valves going to the cooling heating coils inside of an air handling unit. And so we have fully closed up to almost fully open for the heating, and the cooling is almost up there. So is this an example of good or bad, and why? Got one answer so far. Sorry about that. I don't know why this moved. So if you're trying to understand, so is it good or bad? First of all, we have the valve looks like it's completely closed at nighttime from about 12 at night to 6 in the morning. That's probably good, right? We don't need heating or cooling at nighttime typically. But then comes 6 o'clock in the morning or a little beforehand, the heating valve opens up to 100% and kind of stays mostly up there, drops down sometime in the evening, jumps back up, drops back down. So what's going on here? And then, at the same time, the chilled water valve is open at 60% or more for most of the time. So is this good or bad operation, folks? I mean, is this an example of simultaneous heating and cooling? Exactly. Yeah, we have several people now all saying, yep, simultaneous heating and cooling. No economizer or economizer is not operational. Possibly. It's possible that it's more of an indirect call about the economizer. I wouldn't conclude that necessarily with the economizer. But the fact that we have basically the chilled water and the hot water valves fighting each other in order to meet the desired discharge temperature set points, right? Most likely, the hot water valve could be open much, a fraction of that, 50% or lower. And you'd expect to see this probably vary. I mean, it would be nice. I should have the outside air temperature here. That might be helpful as well. But so this is the kind of stuff you're going to see in the energy charting metrics. The eCam tool will help plot these things to make it very much easier to understand what issues are going on. It's not going to jump right out and say, here's the problem. But the retuning process that we go through, there's a very specific set of sequences and a bunch of typical things and issues to look for and how to look for them for each one of the major building components. The VAV mixing boxes, the air handling units, I think I may have used an expression or abbreviation before. AHU stands for air handling units. And so the process, it's very methodical, goes by equipment piece by equipment piece. Sorry, I'm talking and reading the questions at the same time. It looks like most of you got the concept that this is a simultaneous heating and cooling. And this is what you would look at, and the tool helps set it up to make it very straightforward and really the process. So if you are interested in learning more about this, in either applying this to your own buildings and integrating as part of your operation maintenance, or adding it as part of your consulting service to your energy audits and your benchmarking services that you provide to property owners, we're going to be delivering this training upcoming in August and September and November. The small building retuning that we mentioned earlier is going to be delivered later in September and October, November. Again, if you're interested in seeing that webinar, actually both of these webinars, we will email us and we can forward you the link and you can watch these webinars again, this little introduction to it. The training webinars will be a live format spread out, like typically 4 hours for the large building retuning, 4 hours spread out over the course of 5 days. There's a lot of material to cover, and you actually are going to have the eCam tool and you're going to use it and go through examples while we go through the training. So the trainings are going to be interactive. for the small and for the large building retuning, we ask the participants to report on findings and issues that they find in their own buildings or buildings they're working on. That's more geared towards the small retuning training. For the large retuning training, there will be short little, homework exercises or things to ponder, kind of like the question we just went over tonight. And then in the next day we can talk more about it and go over your findings. The trainings are approved for PDHs, professional development hours, and if you are a New York State consultant or work for a company in New York State, there is a 50% discount through NYSERDA. You don't have to be in New York State or work in New York State, though, to attend these trainings. They are open to everybody. It's just there's a discount for New York folks. So now going back to people's questions, I'm going to try to go in order of what we had here. Patterns. So really the question was, how do you integrate, would an infrared or thermal scan of the shell be part of retuning process, and why not integrate ASHRAE protocol into the whole process? Definitely. I mean, if you can bundle this process as part of a larger value proposition to the property owner, go for it. Definitely a great thing to do. Like I said, there is a component of this large building retuning is to walk through the building. Not in the kind of detail you might do for an ASHRAE audit, but to verify that you understand, I'm looking at air handling units 1 through 4, and I know exactly, according to the drawings, they are delivering air to these floors or these zones, and I walk through to verify, yep, I know what's going on those floors, so that when I see wacky data trends, I either know that's a problem or no, that's actually the way that floor, the schedule on that floor. They leave for 4 hours in the middle of the day, something like that. So the walkthrough is important. The thermal scan, great stuff to do. It's probably not going to tie directly into analyzing the building automation system data trends, but it's definitely a good part of the overall audit process. The small building retuning relies much more on using diagnostic tools like a thermal camera, as well as other measuring devices, and it's more observation-based. Any other questions about the retuning process or the trainings that we're going to deliver on these retuning processes? Some really great questions so far. And if you want more information, here's the link for the training schedule. You can email Lauren, and she will, for instance, send you the link to the pre-recorded webinars, today's as well as the one on the small building retuning, or get back to you on other questions. Looks like we have a few more questions here. The question is, are there building automation systems that don't do trending? Typically, the building automation systems have a trend history or a trend log, they call it. It's a lot of times they're not automatically set up. It's a good question. A lot of times you have to, this minute by minute or 15-second data is happening, and it's, showing the building operators displays of what's going on currently, that hour, that day. There might be fault detection. This is different than fault detection in a way. Fault detection is usually if this value hits this point, send an alarm, and the operator goes and changes something, right? But the trend historian is a lot of times not set up on the BA, on the building automation system. A lot of times you have to send it up. So you might go there for the audit and find that you can't analyze any data already. You need to set it up to record data for specific data points, not just the entire building automation system itself, but you have to go through and say, I want to record every one of these little set points on this air handling unit, and do the same thing on air handling units 2, 3, and 4, and get the boiler settings, you have to set these things up and then record it. And typically, you want at least 2 weeks of data to analyze. And typically you want to do this at different times of the year. The shoulder seasons between heating and cooling are a great time to catch things like, is the economizer working properly or not? You'd like to do in the summertime to catch the chiller operation, the wintertime to catch the boiler operations. But sometimes you can get lucky and the shoulder season, could catch everything. You might be able to catch issues with the chiller and the boiler in the shoulder seasons. Looks like we had a couple more questions. Good question. Any difference between retuning and retrocommissioning, or is this a subset? Yeah, there is a distinction. It's a really great question. Retuning is really, at least this large building retuning, is very focused on using the data from the building automation system and making recommendations for changing set points in the building automation system. If something is really out of whack and it doesn't make sense with the settings, you might go investigate in the field to find, wow, there's the dampers on the air economizer are stuck, and they're stuck open, closed, or in one fixed position. And then in that case, the maintenance staff may correct that, or there's a faulty sensor and correct that. Correcting those kinds of sensors and things like that in the field are more under retrocommissioning. And retrocommissioning is more of a process where you're testing, does an individual piece of equipment function the way it was designed to function, taking it through a whole series of tests. And it's typically done in the field. And to me, that's like more of a micro picture. You're looking at one piece of equipment at a time. The beauty of this retuning is you're looking at the whole. You could have too many pieces of equipment, but you might do a sampling, say, of your air handlers, 3 or 4 out of the 10 or 20 you have in this large building, and you're able to look at portions of your entire building, or start with the demand draw. You can record at minute intervals, 5, 15-minute intervals from the BAS or possibly your interval electricity meter, and just look at the energy profiling of your building first, and start at a larger view and say, do we have issues? We're up at 100 kW when everything's at nighttime. What is really running at nighttime that needs to really be running? So I think retuning is macro view. It's looking at the actual control settings. It's utilizing the BAS trends. Retrocommissioning is more equipment by equipment piece of, is it operating the way it was designed to, and is it still, is it functioning correctly? And if not, how are we going to, correct that? So there is some overlap, but I think that is the distinction. Has it been a challenge working with different BAS systems and vendors? You betcha. That is the downfall of, not downfall, that's the biggest challenge overall, is getting the data out of the building automation system. Our experience has been automated logic is great. Johnson Controls, you really need to know their systems, like be a controls vendor and know them, or have someone, have one of them help you get the data out. Certain systems are just easier to to set up the trend historian and get the trend data out. Some are very difficult to understand and kind of locked down. So that to me that's usually the biggest cost on our part, to do this, is getting the trend data from the building automation system. Again, you set it up once and you get the data out once. You set up your eCam. It's an Excel tool or an Excel VBA code built into an Excel environment. But you set it up once with these trends, set up all these, the series of charts that you're used to looking at once. You figure out what the issues are. That's going to take you the majority of the time. To repeat this process next quarter or a month down the road is going to be a fraction of the time getting the data out of the BAS, because you've already done it once. You've already got the trend historian set up. It's just getting new data out of the system. And you can append new data to your old data in the eCam tool, reset, basically rerun the charts. It's kind of like, in Excel, you're used to refreshing the charts. Hey, is everything still copacetic or not? Or we made changes. Did the changes stick, and is it fixed or not? So again, getting back to the amount of time and the challenge of this is the initial setup. And I think a good model is to possibly have the consultant come in and help you with, help the staff the first time, set up the BAS. Maybe someone on staff knows how to get the data out of the BAS, but help set up the eCam tool. A lot of times, maybe the staff aren't so savvy with Excel and how that works. You get it all set up for them. do the initial findings and recommendations, and say, look, here's the process for repeating this and integrating this into your operation maintenance practice each month or each quarter, and hopefully it's a matter of a few hours or less than a day's time for them to do it, not many days of time like it probably is going to take you to do the initial setup. So there's typically typically no capital cost, but there's definitely an initial time cost for getting the data out of the system. But a very, very powerful tool. You're utilizing this very rich data that typically is just being shown each day to the operations staff, and then it just gets erased. It's not being used for anything. It's a very, very rich data set, and the more we can leverage this to correct issues, the better. And typically, besides 5 to 20% kind of energy savings, that's been found in a lot of case studies, a lot of comfort issues are taken care of. And when they've surveyed the tenants of these buildings, typically there have been increases in comfort, or fewer complaints about comfort. As much as 50% of the tenants have said, yep, this is much more comfortable, or 50% of them or fewer now complaining about it's too hot, it's too cold, the air is blowing too hard, discharge, the air is blowing too hard across my desk, all kinds of issues like that. So and it's definitely a piece of the audit process, and possibly getting your an Energy Star rating on your building. You can definitely drop your increase your EPA portfolio manager score, because this is reducing operation issues, reducing your energy consumption and demand consumption in your building. So if there are no other questions, I'm going to wrap it up here. Again, go to the link about the trainings. Email Lauren McFeely at psdconsulting.com if you have other questions or want to get the link to these little introduction webinars on large and small building retuning. Thank you, everybody, for your time. Have a great day, and hope to see you on the trainings. Thank you.